Welcome back, guys. In this video, we are diving into advanced math problems on sequences and series, perfect for high school, college prep, JAMB exams, IGMB exams, the WAEC or NECO exams, JUPEB exams, SET exams, IGCSE exams, CBSE exams, and other competitive exams. Guys, let's go beyond basics and master the concept with real exams type problems and step-by-step solutions. Basically, we have two types of sequences. The first one being the linear sequence, also called the arithmetic progressions or the AP, and the second one is exponential sequence, also called the geometric progression, GP. So guys, sit back, relax, and watch me cite various examples with full solutions involving the sequences and series. So we start with the linear sequence, also called the arithmetic progression. Now let's look ahead to find the nth term of our linear sequence. Find the 40th term of the following sequence: 6, 11, 16, and 21. The nth term of our linear sequence is gotten using this formula: Tn equal a plus n minus 1d, where Tn means the nth term of the sequence, a is the first term of the sequence. Every number on this sequence is called a term. So the first term, being the first number on this sequence, is 6 and is designated by a, or the T1. Going back to our formula, we could see n. N here represents the term we are being asked to find. In our question, we are asked to find the 40th term. So our n is 40. D here is a constant number called the common difference. Common difference, D, is the difference between a term and the term immediately preceding it. For example, looking at this sequence, the difference between 6 and 11 is 5. Also, the difference between 16 and 11 is also 5. Lastly, the difference between 21 and 16 is 5. Therefore, we could see that the difference D is constant, being 5. Now, let's find the 40th term of this sequence by substituting all these values into our formula. We have T, N. We did say our N value is 40, so we have T40 equal A. We did say our A value is 6 plus N. 40 minus 1, D value is 5. 6 plus 40 minus 1 multiplied by 5. 6 plus 39 multiplied by 5 gives 195. 6 plus 195, 201. Therefore, the 40th term of this sequence is 201. Now, let's solve the second challenge. The fourth term of an arithmetical progression is 15. That is T4 equal 15. And the ninth term is 35. That is T9 equal 35. Find the 15th term. So we'll be asked to find the 15th term. This is the usual formula which we use in finding the nth term of an AP. Tn stands for the nth term of the AP. We were given the fourth term as 15. So going by our formula, the fourth term will be a plus n. Our n value being 4, that is the fourth term. 4 minus 1 gives 3. So 3 multiplied by d, 3d, equal to 15. Therefore, a plus 3d equal 15, be called equation 1. Let's look at the ninth term. Going by our usual formula, the ninth term will be called a plus n. N value being 9 minus 1. Minus 1, 8. 8 multiplied by d, 8d, equal 35. Therefore, a plus 8d equal 35. Be called equation 2. Subtract equation 1 from equation 2. This equation 2, we expected to subtract equation 1, being this, from equation 2. A minus a, 0. 8d minus 3d, 5d, equal to 35 minus 15. Now let's find the value of d from this point. D will be equal to 20 divided by 5 gives 4. Since we've gotten the value of d being 4, so we could get the value of a from equation 1. Equation 1 is a plus 3 multiplied by d. Our d value is 4. So in place of d, we write 4 equal to 15. A plus 3 multiplied by 4 equal to 15. Collecting like terms, we have a equal to 15. When positive 12 crosses to the right hand side, becomes negative 12. Therefore, a will be equal 15 minus 12, 3. Proceed to getting the 15th term. Going by our usual formula, Tn, that is the 15th term, will be equal to a. Our a value will get 3 plus n, our n value being 15, minus 1. Multiply by d, our d value will get 4. So we have 3 plus 15 minus 1 multiplied by 4. 3 plus 14 multiplied by 4 gives 3 plus 56, 59. Therefore, the 15th term is 59. If at this point you are getting value and yet to subscribe to my channel, please kindly subscribe. Thank you. Now let's solve the third challenge. The fifth term of an arithmetic sequence is 17. That is T5 equals 17. Applying our usual formula, T5 will be equal A plus N being the fifth term, 5 minus 1 D. 5 minus 1 gives 4. 4 multiplied by D gives 4D, which is equal 17. And the 12th term is 38. That is T12 equal 38. Then applying the usual formula, T12 will be equal A plus N. N value here is 12 minus 1 D. 12 minus 1 gives 11. 11 multiplied by D, 11D, which is equal 38. Therefore, we have A plus 4D equals 17. Let's call this equation 1. And A plus 11D equals 38. Let's call this equation 2. Now we'll subtract equation 1 from equation 2. A minus A, 0. 11D minus 4D, 7D equal to 38 minus 17. Now let's find D, being the common difference from this point. D will be equal 21 divided by 7, 3. So we've answered the B part of the equation. Let's find A from equation 1. Equation 1 is A plus 4 multiplied by D. At D value we got 3 equals 17. We have A plus 4 multiplied by 3 equals 17. Collecting like terms, A will be equal 17. When positive 12 crosses to the right hand side, it becomes negative 12. So A is equal 17 minus 12, 5. So we've been able to find the first term being A. Now let's answer the C part of the question, which asks us to find the 25th term. That is T25. Applying our usual formula, our 25th term will be A plus N, being 25 minus 1, D. A plus 25 minus 1 gives 24. 24 multiplied by D, 24D. 25th term will be A plus 24D. So we have A. We got the value of A to be 5 plus 24 multiplied by D. Our D value is 3. We have 5 plus 24 multiplied by 3, 72. 5 plus 72 gives 77. Therefore, the 25th term is 77. So let's answer question number 4. If 8, x, y, z, and 20 are in arithmetical progression, find x, y, and z. In the given sequence, we could see that the first term here is 8, which is designated by T1 or A. Going back to the sequence, this is T1, that is the first term, second term, third, fourth, and fifth. So we are given the fifth term, that is T5, to be 20. So at T5, using our usual formula will be A plus N. Our N value is 5 minus 1, D. So we have A plus 5 minus 1 gives 4. 4 multiplied by D, 4D, which is equal to 20. So we already know the value of A, that is the first term. So we fix the value of A being 8 into this equation. A being 8 plus 4D equal to 20. We'll find the value of D from this point. We'll have 4D equal 20. When positive 8 crosses to the right hand side, it becomes negative 8. 4D equal 20 minus 8. D will be equal to 12 divided by 4, 3. So now we know the value of A being the first term, and we also know the value of D. That is the common difference. Proceed to finding the value of X, Y, and Z. 8 is the T1, that is the first term. X is the T2, that is the second term. Adopting our usual formula, T2 will be A plus N2 minus 1, D. A plus 2 minus 1 is 1. 1 multiplied by D, D. T2, which is X, is A plus D. We know the value of A being 8. We also know the value of D being 3. Let's fix these values into T2. A is 8 plus D, 3. 8 plus 3 gives. Therefore, our X value is 11. Y is the third term, T3. Employing our usual formula, T3 will be equal to A plus N being 3 minus 1, D. A plus 3 minus 1. 2 multiplied by D. So Y equals A plus 2D. Now let's fix the value of A and D into this formula to derive the value of Y. A value is 8 plus 2 multiplied by D. And D value is 3. 2 multiplied by 3 gives 6. 8 plus 6 gives. So Y being the third term is 14. Now let's proceed to finding the value of Z. Z is the fourth term. Adopting the usual formula, T4 will be A plus N, and N value is 4 minus 1. 4 minus 1 is 3. 3 multiplied by D gives 3D. Therefore, Z is A plus 3D. Let's fix the value of A and D into this formula. Z will be called A. A value is 8 plus 3 multiplied by D. D value is 3. 8 plus 3 multiplied by 3, 9. 8 plus 9 gives 17. Therefore, the Z value is 17. Now, let's answer question number 5. Find the value of x. Given that x plus 1, 2x, and 2x plus 3 are consecutive terms of a linear sequence. If x plus 1, 2x, and 2x plus 3 are in arithmetical progression, and D is a common difference, then D equals 2x plus 3 minus 2x. 2x minus 2x is 0. Therefore, D will be called positive 3. Also, D will be called 2x minus x plus 1. So, we already have value for D, which is 3. Fixing 3 here equal to 2x minus x gives x. Negative multiply positive 1 gives negative 1. Now, from here, we'll find that x value. X will be called 3. When negative 1 crosses to the left-hand side, becomes positive 1. So x equals 3 plus 1. So we've been able to find the value of x, which is 4. Guys, if you are getting value and at this point you are yet to subscribe to my channel, please kindly subscribe. Thank you. Now let's solve the sixth challenge, which asks us to find the 10th term of the arithmetic sequence 3, 7, 11, 15. Looking at this sequence, we could see that the first term is 3. Then the common difference D will be equal either 7 minus 3 or 11 minus 7 or 15 minus 11, 4. We're asked to find the 10th term, that is T10. A plus, A value is 3. So in place of A, we'll write 3 plus N, which is 10 minus 1, 9. Then multiply by D, 4. 3 plus 9 multiplied by 4, 36. 3 plus 36 gives. Therefore, the 10th term is equal to 39. Before we proceed to learning how to find the arithmetic mean of linear sequence, if you are getting value and at this point you are yet to subscribe to my channel, please kindly subscribe. Thank you. Instead the arithmetic means between 19 and 35. Let the arithmetic means be P, Q, and R. Then 19, P, Q, R, and 35 are in arithmetical progression. So that 19 is the first term designated by T1 or A, while 35 is the fifth term. Adopting our usual formula, T5 will be A plus N minus 1, D, 4 multiplied by D, 4D, equal 35. So T5 is A plus 4D equal 35. Let's call this equation 1. Now let's substitute value of A being 19 into equation 1. A value is 19 plus 4D equal 35. Collecting like terms from this point, we'll have 4D equal 35. When positive 19 crosses to the right hand side, becomes negative 19. So 4D equal 35 minus 19. So D will be equal to 16 divided by 4. Now we know the value of A being 19. We also got the value of D. Find the value of P, Q, and R. Looking at this sequence, P is the second term, that is T2. And going by our usual formula, P or T2 will be A. We already know the value of A to be 19 plus N, 2, minus 1. 2 minus 1, D. D value is 4. So 4 multiplied by 1, P is equal to 19 plus 4. Now let's find Q. Being the third term, employing the usual formula, T3, that is Q, will be A. A value is 19 plus N. N is 3 minus 1, D. And D value will get 4. 2 multiplied by 4, 8. 19 plus 8 Q value is 27. Now let's find R. Applying our usual formula, we have A. A value is 19 plus n minus 1. 4 minus 1. D. D value is 4. 3 multiplied by 4. 19 plus 12. Therefore, R value being the fourth term is 31. Hence, the three arithmetic means are 23, 27, and 31. Now, let's look ahead to find the sum of n terms of an arithmetical progression. Find the sum of the first 20 terms of the sequence. 5, 8, 11. Looking at the sequence, we could see that the first term is 5. The common difference D could be gotten by subtracting 5 from 8 or subtracting 8 from 11. D equals 3. N is 20 because we are asked to find the first 20 terms. We use this formula in finding the sum of the n term of an arithmetic progression. Sn, that is the 20 terms, equal n 20 divided by 2, 10. 2 multiplied by A value is 5, so 2 multiplied by 5, 10 plus n minus 1, 19. D, 19 multiplied by 3, 10 plus 57. 10 multiplied by 67 gives. Therefore, the sum of the first 20 terms is 670. Having solved various challenges that has to do with linear sequence, also called the arithmetic progression, AP. Now, let's proceed to solving numerical problems that has to do with exponential sequence, also known as geometric progression, GP. We'll start with finding the n term of geometric progression. Now let's look at this challenge. The second term of an exponential sequence is 35. That is T2 equal 35. And the fourth term is 875. That is T4 equal 875. Find the first term, T1, and the fifth term, that is T5. This is the usual formula used in finding the n term of geometric progression. We are given the second term, T2, to be 35. Employing our formula, T2 equal AR raised to power n value is 2 minus 1 equal A, 2 minus 1. So the power of R here is 1 equal 35. We're also given the fourth term. And employing our formula, we have T4 equal AR raised to power n value here is 4, n minus 1 equal AR raised to power 4 minus 1, 3 equal 875. Now let's call AR raised to power 3 equal 875 equation 2, while we'll call AR equal 35 equation 1. Divide equation 2 by equation 1. So we'll divide AR raised to power 3 by AR, which is equal 875, divide by 35. AR raised to power 3 entails A multiplied by R multiplied by R multiplied by R, and then divide by A multiplied by R equal 875 divided by 35. The A at the numerator eliminates the A at the denominator. R here eliminates the R at the denominator. So on the numerator we are left with R squared, that is R multiplied by R, equal 875 divided by 35, 25. Now let's find R. R will be the square root of 25, 5. Now we've gotten the value of R. Proceed to finding the value of A. That is the T1 being the first term from equation 1. Equation 1 is AR equal 35. Now we'll fix the value of R being 5 into this equation. A multiplied by R. R is 5 equal 35. 5 times A, 5A equal 35. A value will be 35 divided by 5, 7. So we succeeded in finding the value of the first term, T1. Now let's also proceed to finding the fifth term, T5. Going by our usual formula, T5 will equal AR raised to power n being 5, minus 1. We have AR, 5 minus 1. Now let's substitute the value of A and R into T5. A multiplied by R value is 5 raised to power 4 equals 7 multiplied by 5 raised to power 4 gives 7 multiplied by 6 to 5. Therefore, the fifth term is 4375. If you are getting value and at this point you are yet to subscribe to my channel, please kindly subscribe. Thank you. Now let's solve the next challenge. An exponential sequence is such that the third term, that is T3, minus the first term is 48. The usual formula for calculating geometric progression. T3 will be AR raised to power n 3 minus 1. 3 minus 1 minus T1. T1, which is A, the first term, equal 48. The fourth term minus the second term is 144. Applying the usual formula, fourth term will be AR raised to power n being 4 minus 1. 4 minus 1. Therefore, the fourth term will be AR raised to power 3 minus T2. Applying the usual formula, T2 will be AR raised to power n being 2 minus 1. 2 minus 1, the power of r here is 1, equal 144. Let's call this equation 1. Also call this equation 2. Before we proceed to finding the common ratio r, let's multiply equation 1 by r. L multiplied by ar square minus r multiplied by a equal 48 multiplied by r. Let's call this equation 3. Equating equation 2 and 3, 48r will be equal 144. Now from this point, we could find the value of r, that is the common ratio. R will be equal to 144 divided by 48, 3. Now let's find the first term, a, from equation 1. A multiplied by r square, r value will get 3 square minus a equal 48. A multiplied by 3 square minus a equal 48. 9 multiplied by a minus a equal 48. 9a minus a equal 48. A will be equal to 48 divided by 8, 6. Now let's answer the C part of the question to find the sixth term of the sequence. Employing the usual formula, the sixth term will be equal AR raised to power n being 6 minus 1. 6 minus 1 gives 5. So this is AR raised to power 5. Let's substitute the value of first term and the common difference value to find the sixth term. A multiplied by r value is 3 raised to power 5. 6 multiplied by 3 raised to power 5. The sixth term will be equal 6 multiplied by 243, 1458. If you are getting value and at this point you are yet to subscribe to my channel, please like and kindly subscribe. Thank you. Now let's take a look at this challenge. Find the two possible values of p if p minus 3, 3p plus 5, and 18p minus 5 are the three consecutive terms of geometrical progression. If p minus 3, 3p plus 5, and 18p minus 5 are the three consecutive terms of a geometrical progression, then 3p plus 5 divided by p minus 3 equal 18p minus 5 divided by 3p plus 5. P minus 3 here multiplies this equal 3p plus 5 here multiplies this. P multiplied by 18p. P multiplies negative 5. Negative 3 multiplies 18p. Negative 3 multiplies negative 5. 18p square, negative 5p plus negative 54p plus 15. 3p multiplied by 3p. 3p multiplied by 5. 5 multiplied by 3p. 15p plus 15p gives 5 multiplied by 5. Now let's collect like terms. 18p square, when positive 9p square crosses to the left hand side, becomes 18p square minus 9p square gives, here we have negative 59p. When positive 30p crosses to the left hand side, becomes, so negative 59p plus negative 30p plus 15. When positive 25 crosses to the left hand side, becomes 15 minus 25. Negative 10 equals 0. 9p square, 9 multiply negative 10 minus 90 plus 1 gives minus 89. Therefore, minus 89p will be minus 90p plus 1p. Then minus 10 equals 0. 9p is the common factor between 9p square and negative 90p. By the time we bring out 9p, we'll be left with p here. When we remove 9p from negative 90p, we'll be left with negative 10, because 90p multiplied by negative 10 gives negative 90p, plus 1 is the common factor between p and negative 10, equals 0. Now let's pair 9p and 1. P minus 10 here, so also here. So we'll pick 1 equals 0. Either 9p plus 1 equals 0, or p minus 10 equals 0. So if we say 9p plus 1 is 0, So 9p will be equal, when positive 1 crosses to the right hand side, becomes negative 1. P will be equal negative 1 divided by 9. Or if we say p minus 10 is 0, p will be, when negative 10 crosses to the right hand side, positive 10. So the two possible values of p is either minus 1 over 9 or 10. Let's look ahead to find the geometric mean of an exponential sequence. Insert two geometric means between 12 and 324. Let the geometric means be x and y. Then 12, x, y, and 324 are in geometric progression. Looking at this sequence, we could see that 12 is the first term, designated by T1 or A. 324 is the fourth term. Applying our usual formula, T4 will be equal to AR raised to power n 4 minus 1. 4 minus 1 equal 324. Call this equation 1. And call A equal 12 equation 2. Divide equation 1 by equation 2. AR raised to power 3 divided by A. A at the numerator eliminates the A here. We are left with R raised to power 3 equal 324 divided by 12. Now, to get the value of R, we'll take the cube root of 27. 3. Find x value. X is the second term, T2. Applying the usual formula, T2 will be AR raised to power n minus 1, 2 minus 1. Therefore, the power of R is 1. Now, we're facing the value of A being 12 and R 3. To derive x value, T2, A multiplied by R, 12 multiplied by 3. Therefore, x value is 36. Y is the third term, T3. Applying the usual formula, T3 will be AR raised to power n 3 minus 1. 3 minus 1. Therefore, T3 is AR raised to power 2. Now, let's insert the value of A and R to get the value of Y. A multiplied by R square, the square of 3, 12 times 9. So, Y value is 108. Hence, the two geometric means between 12 and 324 is 36 and 108. Before we proceed to learning how to find the sum of n terms of geometric progression, guys, if you are getting value from this video or you are yet to subscribe to my channel, please kindly subscribe. Thank you. Now let's look at this challenge. Find the sum of the first systems of an exponential sequence 18, 6, 2. 18 is the first term in this sequence. A is 18. Let's find the common ratio. Common ratio R will be 2 divided by 6 or 6 divided by 18, 1 over 3, which is approximately 0.333. We use any of these formulas to find the sum of n terms of geometric progression, and the formula to apply depends on the value of R. So if R is greater than 1, we use this formula. However, if R is less than 1, we apply this formula. Obviously, our value here is less than 1, so we apply this formula in finding the sum of the first systems of the sequence. So the sum of the first systems is equal to A, 18, multiplied by 1 minus R raised to power n, 6, because we are asked to find the first systems. Then divide by 1 minus R, 18 multiplied by 1 minus 1 over 3 raised to power 6, 1 over 729. And then divide by 1 minus 1 over 3, 2 over 3. 18 divided by 2 over 3 means 18 multiplied by 3 divide by 2. 18 multiplied by 3 divide by 2. 27 multiplied by 1 minus 1 over 729 gives 728 over 729. 27 multiplied by this. Therefore, the sum of the first systems of the exponential sequence is 728 over 27. Now, let's look at this challenge. The third term of a geometrical progression is 63. Applying the usual formula for finding the n term of geometric progression, T3 will be AR raised to power n 3, then minus 1. 3 minus 1 equals 63. And the fifth term is 567. Then applying the usual formula, fifth term will be AR n 5 minus 1. 5 minus 1 equals 567. We are asked to find the sum of the first systems. Let's divide this by this. A here eliminates this A. So the 2R here eliminates 2R here. At the numerator, we are left with R squared. 567 divided by 63. R will be equal square root of 9. Let's find the value of A from this point. A multiplied by R squared. R value is 3 square equals 63. 3 squared is 9. 9 multiplied by A, 9A equals 63. A will be 63 divided by 9, 7. Since our value is 3 and is greater than 1, we apply this formula in finding the sum of the four systems. The sum of the four systems will be equal to A multiplied by R raised to power n. Remember, we are asked to find the sum of the four systems. So n value is 6 minus 1. 3 raised to power 6 minus 1. 729 minus 1 divide by R, 3 minus 1. 7 multiplied by 728, 3 minus 1. 5092 divided by 2. Therefore, the sum of the four systems of the progression is 2548. Guys, finally, we are in the last question. In this question, the AP and the GP were merged. The first, third, and the ninth terms of a linear sequence. This is the usual formula for getting the nth term of a linear sequence, where A is the first term. The third term will be A plus n, 3 minus 1, 3 minus 1, D, that is A plus 2D. The ninth term will be A plus n, 9 minus 1, 8 times D. So the ninth term will be A plus 8D. So these are the first, third, and the ninth term of a linear sequence. And the first three terms of an exponential sequence. The first three terms of an exponential sequence are applying the usual formula. The first term is A, the second term is AR raised to power n, 2, that is the second term, minus 1. 2 minus 1, 1. So the power of R is 1, second term. The third term will be AR raised to power n being 3, that is third term, minus 1. So 3 minus 1. So these are the first three terms of an exponential sequence. Let A plus 2D equal AR be called equation 1. And let A plus 8D equal AR squared be called equation 2. Going back to the question, if the seventh term of the linear sequence is 14, applying the usual formula, seventh term will be A plus n. N is 7 minus 1. 7 minus 1 is 6. D, 6 multiplied by D, 6D, equal 14. Let's call this equation 3. Now let's make R the subject of formula from equation 1. From equation 1, R will be equal A plus 2D divided by A. Call this equation 4. Now let's use GP condition to tackle this challenge. In our GP, the square of the middle term is equal to the product of the outer terms. Now let's expand both sides. A plus 2D squared means A plus 2D multiplied by A plus 2D equal A multiplied by A plus 8D. A times A squared, A multiplied by 2D. 2D multiplied by A, 2D multiplied by 2D. A multiplied by A plus A multiplied by 8D. A squared here eliminates the A squared here. 2AD plus 2AD plus 4D squared equal 8AD. 4D squared equal to 8AD. When positive 4AD crosses to the right hand side, becomes negative 4AD. 4D squared equal 8AD minus 4AD. 4D squared entails 4 multiplied by D multiplied by D equal 4 multiplied by A multiplied by D. 4 here eliminates this. D on the left hand side eliminates this. So on the left hand side, we are left with D equal A on the right hand side. This entails that D is equal to A, assuming D is not equal to 0. Now from equation 3, substitute D equal A. Equation 3 is A plus 6D. We did say substitute D for A. So in place of D, we write A equal 14. A plus 6A, 7A equal 14. A will be 14 divided by 7, 2. Now let's derive our value by fixing 2 as the value of A in equation 4. R equal A plus 2 multiplied by D. Remember, we did say D is equal to A. So in place of D, we substitute the value of A. 2. 2 multiplied by 2 divided by A. 2 plus 4 divided by 2. 6 divided by 2. So F value is 3. Now let's proceed to calculating the 20th term of the linear sequence. Applying the usual formula for finding the nth term of a linear sequence, T20 will be equal to A, 2 plus N minus 1, 20 minus 1, D. We did say D is equal A value is 2, So also D value is 2. 2 plus 19 multiplied by 2. 2 plus 38. Therefore, the 20th term of the linear sequence is 40. Now, let's answer the II part of the question, which asks us to calculate the sum of the first 12 terms of the exponential sequence. Since f value being 3 is greater than 1, we use this formula to find the sum of the first 12 terms of the sequence. A multiplied by r raised to power n. Our n value is 12 since we are asked to find the sum of the first 12 terms. Then minus 1 divided by r minus 1. 2 multiplied by 3 raised to power 12 minus 1 divided by 3 minus 1 equal 2 multiplied by 531441 minus 1 divided by 2. 2 at the numerator eliminates the 2 at the denominator. So the sum of the first 12 terms of the exponential sequence is 531440. I hope this video is clear enough. Please, if you really got value and at this point you are yet to like this video and subscribe to my channel, please kindly subscribe. Also do well to share this video with anyone who might find it useful. Comment with any questions or topics you want us to cover in future video. Give this video a thumbs up. Thanks so much for watching. See you in our next video. Bye.